Okay, here are the solutions for the final exam. So question number 1 says if you have an equilateral triangle and you rotate it around one of its medians, so let's say this is the median. It's moving. That's the median right there. It's just going to keep going, spinning around and around and around, and that will eventually turn into a cone. Okay, for number 2, we have an equilateral triangle again. Sorry, this is so dark. All these sides are equal. And each side has a length of 20. And we need the height of the equilateral triangle. So the height is going to be the perpendicular line, like that. And in order to find that, we're going to use the Pythagorean theorem. I know that this side is 20, that's my hypotenuse. This is going to be 10. So how do I know that? Because this piece here is equal to this piece, because these two triangles are congruent. How do I know that they're congruent? Because I have a side over here equal to a side here. This side is equal to itself by the reflexive property. And I know that this angle down here is equal to this angle down here, because all the angles are equal in an equilateral triangle. So I have angle, angle, side. And I know that by CP/CTC, the two pieces will be equal. So that's why that's 10. And this is our height over here that we're looking for. I'm just going to do the work up here where it's a little bit lighter. Okay, so I'm going to have x squared plus 10 squared equals 20 squared. That's going to give us x squared plus 100 equals 400. Subtract 100 from each side, and you get x squared equals 300. Take the square root of both sides. I'm doing this because it says to the nearest tenth, otherwise I would not be using my calculator for this. And when you use your calculator, you're going to get this, 17.3. Okay, here's problem number 3. And we're given that AD, that's over here, is 4, DB is 6, and we want to know what does AC, so AC is over here, have to be, so that CD is perpendicular to AB, meaning that the hypotenuse rule or the altitude rule, not a hypotenuse, altitude rule or leg rule would work. Okay, so we're going to call this X. So X is a leg, it is not the altitude. So that means we're going to do the leg rule. And the leg rule says that you multiply the leg by the leg, and then you multiply the entire hypotenuse, which is 10, by the projection. And by the projection we mean the piece of the hypotenuse that is closest to this x. So that would be 4. So we're going to get x squared equals 40. Take the square root of both sides, and you get x equals radical 40. Now, that does not match any of the multiple choice answers, so we're going to simplify radical 40. So we can simplify that into 4 and 10. And then the square root of 4 is 2, and we get 2 radical 10, and that is choice 2. Okay, here's question 4, and we're told that these are two similar triangles. So that means that we know that the corresponding sides are in proportion. So tan of theta is 3 over 7. So we should know that tan is going to be opposite over adjacent. Okay, and I'm taking that right from SOHCAHTOA. Okay, so tan of theta is opposite, so if it's 3 over 7, that means that the opposite side, which is over here, is the 3, and the adjacent side, which would not be this side because that's the hypotenuse, is 7. And so now we need to use that to find out what x is over here. So you can see that the 3 corresponds to the 2.4, and the 7 corresponds to the x. So we're just going to cross multiply. We get 3x equals 16.8. And divide both sides by 3. And you get 5.6, and that was choice 2. Okay, here's number 5. So I think it's easiest if we try to picture this on a graph. So we have a rhombus, and the diagonals intersect at P, which is 2, 1. So let's say that's like right here. Okay, so the diagonals are going to intersect of a rhombus right there. So let's say it's going to look something like that. Okay. The equation, okay, so this is rhombus TEAM. So I'm just going to close this up. Make our life a little bit easier. So T, E, A, and M. Okay. The equation of the line that contains TA, so I'm just going to do that in a different color. So TA is this line right here. So the equation of TA is y equals negative x plus 3. So I already know that the slope is equal to negative 1. Okay, let's see what they're asking for. What is the equation of the line that contains diagonal EM? Okay, so what do we know about EM? Well, we know that it must go through the point 2, 1. And we also know that the slope should be the negative reciprocal of the other slope because the lines are perpendicular. The diagonals are perpendicular because it's a rhombus, and that's a property of a rhombus. So the negative reciprocal of negative 1 is just going to be 1. So we're looking for the equation of a line with a slope of 1 that goes through the point 2, 1. So we're going to start off with y equals mx plus b. We know that m is 1. But we really don't have to write 1x, we could just write x, because it's the same thing. And we know that x is 2 and y is 1. So x is 2 and y is 1. Subtract 2 from both sides, and we're going to get that b equals negative 1. So we're going to put the whole thing together. Y equals, because I'm using this right here, x, and now I'm going to replace the b with negative 1. Y equals x minus 1, and that is choice 1. Okay, here's number 6. So as soon as I see that there are line segments in a ratio, I'm thinking of that I need to find the slope, and that I need to start counting up and over. So I'm just going to do this on regular, just a sketch. I don't have graph paper on this. So M has coordinates 3, 5, so let's say that's somewhere around here. And n has the coordinates 8, negative 5. So maybe somewhere around here. Okay, here's n. So here's my line mn. And the first thing we want to do is find the slope of that line. So you can count up and over, or you can use the slope formula. Here's x1, y1. Here's x2, y2. So the slope is going to be y2 minus y1. That's a 1 here. Over x2 minus x1. So this will give us negative 10 over 5. And so m equals negative 2. Okay, so I'm just going to put it over 1 to remind us that we're going to go down 2 and then right 1 until we get to the end. So I go down 2 and to the right 1, and here's a point. And I go down 2 and over 1, and you would do this on graph paper, and you're going to keep going, and keep going, and keep going. So how many line segments do I have here? Here's line segment 1, 2, 3, 4, 5. And I know that's right because 2 plus 3 is equal to 5. Okay, so we want MQ to count as 2 pieces. So MQ, here's the second piece right here. That's where Q should be, right there. So that would be the point 5, 1, which does not look like it from this graph, but that's what it is. Okay, so if you do this on graph paper, it will definitely look a lot better. Okay, so, so that's here, choice 1. Okay, so here's number 7. So we need to first, if we want to look at this on a graph, So negative 5, 12, let's say, would be up here. That's the center. I'm sorry, circle center is the origin. Here's our center. This is a point on the circle. So the circle is going to look something, oh, that's a pretty good circle, something like that. Okay, so we want to know which of these points would also lie on this circle. So because we're dealing with radicals and we may not have graph paper, it would be difficult to graph it perfectly and see. So if we find the equation of the line, then we can test these points. So we know that if we're doing the equation of a circle whose center is at the origin, we can just use x squared plus y squared equals r squared. So the only thing we need is r. So r would be the radius right here from the point negative 5, 12 to the point 0, 0. Okay, so we're just going to use the distance formula to find r. Okay, so it's going to be y2 minus y1 squared plus x2 minus x1 squared. Okay, this is going to give us a negative 2 squared, which is 4, and a 5 squared, which is 25. So we get radical 29. So that means the equation of our circle is x squared plus y squared equals radical 29 squared, right? Because we're putting radical 29 in for r. But when you square a square root, you're left with what's inside. So you get x squared plus y squared equals 29. So that is the equation of our circle. And now we just have to put these points into that equation and find the one that works. Okay, so we'll start with number 1. So this is my x, this is my y. So 10 squared plus 3 squared, does that equal 29? No, because it's 109, so that one does not work. Okay, let's try the next one. Okay, number 2. Negative 12 squared plus 13 squared, does that equal 29? So we get 144 plus 169, that definitely does not equal 29. So number 2 is out. Okay, number 3. 11 squared plus 2 radical 12, all squared, does that equal 29? So we get 121 plus 4, because 2 squared is 4, and radical 12 squared is just 12. Does that equal 29? No. Okay, hold the phone, stop. I just realized that we made a mistake. And when I say we, I mean not me. I don't know, my imaginary friend. Let me go back. Made a mistake on the radius. Let me go back. Sorry, but I don't want to start the video from scratch. Alright, x squared plus y squared equals r squared. So we said we're using 0, 0, and negative 5, 12. Okay, so here we go, do this again. y2 minus y1, I think I wrote 2 instead of 12 before, plus x2 minus x1 squared. Okay, negative 12 squared is 144, 5 squared is 25, we get radical 169, so that's 13. So r equals 13. Okay, so I'm going to put 13 in here. But this is not cooperating. Hang on. Sorry. Alright, I'm going to write here because this program doesn't want to cooperate. X squared plus y squared equals r, which is 13, squared. Okay, so let's get our final result, which is that x squared plus y squared equals 169. Okay, that's the equation of our circle. Sorry about that. Okay, well, this is good practice. We'll do it again. Alright, here's x and y. So 10 squared plus 3 squared, does that equal 169? No, it does not. It equals 109. So 1 is not the answer. Okay, let's try number 2. Here's the x, here's the y. Negative 12 squared plus 13 squared, does that equal 169? 144 plus, what is 13 times 13? Oh boy. Hang on. Oh, it is 169. That's what I thought, and I said something doesn't seem right. Okay. All right, does that equal 169? No. So 2 is out. Okay. It's a little tedious, but it's not so difficult. Okay, let's go to number 3. Here's the x, here's the y. So we have 11 squared plus 2 radical 12 squared. Does that equal 169? So this is 121. Okay, so we have to square both things. 2 squared is 4, and then radical 12 squared is just 12. So we get 121 plus 48, and what do you know? That does equal 169. So 3 is the answer. Okay, here's number 8. So we're given this equation of a circle in a bad form, and we want to change the form. So the first thing we're going to do is we're going to move the constant over to the right side, but they already did that for us, so we don't have to do that. The next thing we're going to do is we're going to group our x and y terms together. So we're going to have x squared minus 6x plus y squared plus 2y equals 6. Okay, if there was a coefficient in front of the x squared and the y squared, we would divide by that coefficient, but there's not. So the next thing we're going to do is we're going to take one of the x's, carry down the sign for the negative. We're going to take this number 6 and divide it by 2. That gives us 3. So it's divide by 2. Plus, take one of the y's, carry down the plus sign, and then we want to take the coefficient of y and divide by 2. So 2 divided by 2 is 1, and that equals 6. So the only other thing we have to do is now square this 3, and this should have squared, and square this 1 and add it to the other side so everything's even. So a negative 3 squared is 9, so we're going to add 9, and a 1 squared is 1. So we should end up with this. Okay, so the center is going to be the opposite signs of these. So we're going to have 3, negative 1, that's our center. So right away you know it can't be that one and it can't be that one. And then you take the square root of that number to find the radius. So therefore the radius is 4. And number 8, the answer was 2. Okay, here's number 9. And so we're just trying to find how many meters above the lake was the man. So that means we're looking for this side here. So this is definitely going to be a trig problem, and if the right angle is here, then that means that this is the hypotenuse. Here's the angle of 32 that we're looking at, so x is the opposite, and that leaves this side as the adjacent. Okay, so we're interested in using the hypotenuse and the opposite. So we're going to look at SOHCAHTOA, and we're looking for a hypotenuse and an opposite, and that's going to be sine. Okay, so we have sine of 32 equals the opposite over the hypotenuse. Okay, so I'm just going to put this over 1, and I'm going to cross multiply, and I get x equals 129.5 times sine of 32. Remember that your calculator has to be in degrees. So you're just going to pop that into your calculator, and you're going to get 68.6 right there. Choice number 1. Okay, and here's the last multiple choice question, number 10. So BC is 12. That's this entire piece here is 12. And FE is 5 more than DE. So if DE is x, FE can be x plus 5, right? 5 more. And we're trying to find FE. Okay, so here's the important part. You have to read the question carefully. That DF is bisecting BC. BC is being bisected. which means this piece is equal to this piece. So if the whole thing is 12, each piece must be 6. So the rule for intersecting chords within a circle is that when the product of the two segments, so 6 times 6, will equal the product of the other two segments, so x times x plus 5. Okay, let's distribute that x. This is a quadratic, so we're going to subtract 36 on both sides. Okay, and we're going to attempt to factor this. So we need a number when multiplied will give us 36, and when combined will give us a 5. So if we do 9 and 4, 9 times 4 is 36, and a positive 9 and a negative 4 is a positive 5, so it works. So we get x equals negative 9 and x equals 4. But a segment cannot be negative, then it wouldn't exist. So therefore the x equals 4. So that means that DE is 4 and EF is 9, and they're asking for FE. So FE is 9, which is choice 2. Okay, and that completes the multiple choice, and now we're going to move on to the long answer questions. Okay, so here's number 11. You really need a compass, but I can't use a compass on this program, so I'm just going to show you how to do it. So you would put your compass on O, and then you're just going to mark some point on the circle, and you're going to open up your compass so that you're measuring that distance, which is your radius. Okay, once you have your compass open the length of the radius, you're going to put the compass on this point, and then you're just going to see where does it hit the circle, and it should be somewhere around there. Okay, and that's our second point. Now you're going to put the compass on the second point, and you're going to do the same thing. You're going to mark it. Here's our third point. You're going to keep going. You're going to keep marking. It's 4. Keep marking. 5. Keep marking. Until you get back to the original place. So we have 6 points here, and we're supposed to construct a hexagon. A hexagon has 6 points. So you're going to use your ruler, and you're going to connect. You would do this with a ruler, not messy like I am. And you're going to connect all these points, and that would be your picture. Okay, here's number 12. So we're told that arc AC equals arc BC. And we're given that BC is 152. So if BC is 152, AC has to be 152. So that means that we have used up, this is 4, 304 degrees of the circle. So the only piece that we did not use was this. So the whole circle is equal to 360. You're going to subtract the 304 that we already used, and we get 56 degrees for this piece right here, for this arc. So all 3 pieces of the arc will give you 360. And we're supposed to be finding this angle over here, which is D. So the rule is that when you have a secant and a tangent intersecting outside of the circle at an external point, that angle, so that's x, is going to equal 1/2 of the difference between the big arc minus the small arc. So we're going to get 94. Half of 94. No, that's not right. 58. Okay, sorry. This is supposed to be... Okay, let me go back for a minute. I don't want to confuse anybody. If I could get this working, that'd be great. There we go. Okay, just going to go back. So we had 152 and 152. That gives us 304. 360 minus 304, I don't know if this is what I did before, gives us 56, not 58. I don't know where that came from. 56. Okay. Whoops. Let's get this out of here. Okay, let's go back to our formula. So we have that x is going to equal 1/2 of the big arc minus the small arc. Okay, so 152 minus 56 is 96, and half of 96 is 48, so x is 48 degrees. Okay, so I think this is the problem number 13 that gave people the hardest time. All right, so we have the water cup in the shape of a cone. So I'm not a great artist, but let's say this is our cone. The height is 4 inches, and the maximum diameter is 3 inches, which means the radius, the biggest radius would be right here at the top, and that radius would be 1.5. So just notice, I'm trying to get the point in there, okay, that if you did the radius somewhere down here, that radius would be not be 1.5. That would be like in a cylinder, then the radius is constant throughout, but this is a cone. So what is the volume of the water? So the first thing you have to think of is the formula for the volume, which was given on the reference sheet. So it's 1/3 pi r squared h. When the cup is filled to half its height. So if the height is 4, half of the height is going to be 2. So we know we can replace that with 2. We have the 1/3 pi, and now we just need the r. Now the problem is that when the cone, so I'll redraw the cone, when the water is over here, when the height is 2, how are you supposed to know what this radius is? Well, if we just cut the height, if you look at the, well, there's two different ways to think of this. You cut the height in 2. You divide it by 2, so that means you would divide the radius by 2. You could think of it like that. And that would give us 0.75, or 3/4, whichever way you want to think about it. Or you could set up a proportion if you wanted to. You could say that the original radius over the height is going to equal the new radius, which we'll call x, over the new height. Cross multiply, 4x equals 3, and therefore x equals 3/4. Okay? It's really a better way, in my opinion, to do it. Okay, so what are we going to get here? We're going to multiply this out, and we're going to get 1/3 times pi. We're going to use our calculator for this piece over here, and that will give us 9/8 if you convert it into a fraction. So we're going to get 9 pi over 24, and that can be reduced to 3 pi over 8. But I mean, you don't have to keep reducing because you need to do it to the nearest tenth. You're going to need your calculator no matter what. And that is going to be approximately 1.17. And we're supposed to find it to the nearest tenth. So it's going to be 1.2. That was the answer for that one. Okay, and finally here is number 14, and I apologize for this poor quality of this picture. Okay, so I took the liberty of graphing the picture, and the first thing that we want to do is we want to prove that this thing is a rhombus. So we have some different ways that we can do this. For many of you, you use the distance formula, and that's fine. You'd have to do it for all 4 sides. So I'm just going to do it for one side just so you see how it's done. So let's say I want to find this side P and Q. So here's P and Q right here. So the distance would be y2 minus y1 squared plus x2 minus x1 squared, all under the square root. This will give me 25 plus 25, so we get radical 50. So if you were to do the distance formula for all 4 sides, you would get radical 50 for every side. And then you would write, since PQRS has all equal sides, it must be a rhombus. Okay, so that would be one way to do it. Another way you could do this without using that formula is to show that the diagonals are perpendicular. So a quadrilateral that has perpendicular diagonals would be a rhombus. So if we draw in our diagonals, so let's find the slope of PR. Okay, so the slope of PR. So I'm going to count up and over. So I'm going to, let me get another color. Here. Okay, so I'm on PR. So here's R. I'm going to go up. This would work. I'm going to go up 2. So I went up 2. Then I'm going to go to the left 1, 2, 3, 4, 5, 6. So it's a negative 6. Let me go back to a different color. Okay, so this was 2 over negative 6. So we can see a little bit better, which gives us negative 1/3. Okay. Now we're going to do the slope of QS. Okay, so I'm here at S. I'm going to count up and then over. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I counted up 12. And over 1, 2, 3, 4. 12 over 4 is equal to 3. Okay, so then you would say, since the diagonals have slopes that are negative reciprocals, the diagonals are perpendicular, and PQRS is a rhombus. Okay, so that's how we're going to prove a rhombus. Okay, let's erase this and make some room. Okay, the next thing we had to do was to prove that this is not a square. So the only difference between the rhombus and the square is that the square has 90-degree angles and the rhombus does not have 90-degree angles. So how could we prove that it does not have 90-degree angles? Well, we can do the slope of PS. I mean, you just have to take any two adjacent sides. So the slope of PS, so I'm going to count up again. 1, 2, 3, 4, 5, 6, 7, and then to the left 1. So up 7 and to the left 1. So negative 7. And then I'm going to find the slope of SR. So the slope of SR, because that's an adjacent side. Or I could do PQ, it doesn't matter. Right, so I'm going to do SR. So here's S. 1, 2, 3, 4, 5. So I went up 5. And I'm going to write 1, 2, 3, 4, 5. And that equals 1. So you can see that these are not negative reciprocals of each other. So you would say adjacent sides are not perpendicular because their slopes are not negative reciprocals. Therefore, PQRS is not a square. And I think we are finally done.